Now the question is, if u is equal to 3 into Lx plus my plus nz whole power 2 minus x square plus y square plus z square and L square plus m square plus n square is equal to 1. So this is the condition. Then show that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square is equal to 0. So the given condition, okay, u equal to 3 times Lx plus my plus nz whole square minus x square plus y square plus z square plus m square plus n square is equal to 1. Then show that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square equal to 0. Now first given function, take given function as u equal to 3 times of Lx plus my plus nz whole square minus x square plus y square plus z square. So this is the given function. Okay, now the first thing is dou square u by dou x square. That means differentiate this function 2 times with respect to x. Again differentiate the same function with respect to y. Again double differentiate the same function with respect to z. Okay, so individually do double differentiation with respect to x and with respect to y and with respect to z and add them and finally use the condition. We will get the required answer as 0. Okay, now I'm differentiating the function. I'm partially differentiating the function with respect to x. Okay, if I differentiate with respect to x, treat x as function and treat y and z as normal variables only. And if you see this part, it is looking like 3 into x square. So what is the dou by dou x of x square function? Dou by dou x of x square function is 2x. So if I treat this total function as x, I can write it as 2x. Okay, so already 3 is here, 3 into, so it can be written as 2x. So 2 into, what is x? In the place of x we have Lx plus my plus nz, but in the place of x something is there. Again differentiate it. Okay, again differentiate, it will become with respect to x. Okay, with respect to x this will become L. Okay, differentiation of Lx is L and my and z. Okay, these we have to consider as constants. So plus partial differentiation of my, because y as constant, total will become 0 and this part also becomes 0, minus partial differentiation of x square is 2x plus y square. Okay, y square is 0 plus z square is 0 because we are partially differentiating with respect to x. Whenever you are partially differentiating with respect to x, treat other variables like y, z as constants only. Okay, so here y square is a constant, partial differentiation of constant is 0, z square is 0 and partial differentiation of x square is 2x. Okay, and my answer is dou u by dou x is equal to 3 2 is 6, this part is Lx plus My plus Nz into L plus 0 will become L minus 2x. So this is my first differentiation. Okay, again, okay, because in the question we need partial differentiation, so that can be written as dou square u by dou x square, okay, which is equal to 6 times, okay, L you write here. Now open the bracket, because L is constant, 6L. Now if you observe Lx, partial differentiation of Lx is L plus partial differentiation of My. I'm differentiating with respect to x, so y is taken as constant, it will be 0 and this part will be 0. Already wrote L in front, minus partial differentiation of 2x is 2. So this is my dou square u by dou x square value, which is equal to 6L into L minus 2, and it will become 6L square minus 2. So treat it as equation number 1. Now again we partially differentiate with respect to y. Okay, given u is equal to, we know already, 3 times of Lx plus My plus Nz whole square minus x square plus y square plus z square. Okay, now partially with respect to y. So remember, whenever you are partially differentiating with respect to y, your x and z considered as constants. Okay, now 3 into, again it's like x power 2, that is x power n. Partial differentiation of x power n is nx to the power of n minus 1. So it will become 2 times of Lx plus My plus Nz power 1. So it is x square, it can be written as 2x. In the place of x, this total part is there. Immediately differentiate with respect to y. If I differentiate with respect to y, Lx will become 0, because when you are doing partial differentiation, only y function will be differentiable, other are constants, plus My will be m, Nz will be 0. So this part is done. Now coming to minus, x square will be 0, y square will be 2y, plus z square will be 0, because I am differentiating with respect to y. So partial differentiation of y square is 2y. These are considered as constants, so 0 and 0. Okay, next, dou u by dou y is equal to 3 2 ja 6 into Lx plus My plus Nz into, this part will be m minus this part will be 2y. Okay, so again differentiate with respect to y again. Okay, so 6m I'm taking out, so differentiation of Lx will be 0 and My will be m and Nz will be 0. Okay, because I'm partially differentiating with respect to y. Minus partial differentiation of 2y is 2, and the final answer is dou square u by dou y square is equal to 6m, here it is m minus 2, so it will be 6m square minus 2. So consider it as equation number 2. Now given function u equal to 3 times Lx plus My plus Nz whole square minus x square plus y square plus z square. So partially differentiate with respect to z now. Already we partially differentiate with respect to x, with respect to y, and now with respect to z. Okay, it will become 3 times of, and if you observe this whole square, so it can be written as 2 times of Lx plus My plus Nz. Okay, and again in the place of x something is z, immediately differentiate it, it will become 0 plus n. Okay, because I'm differentiating with respect to z, so with respect to z these two become 0, x and y will treat it as constants, minus this is treated as constant, this is treated as constant, z square will be 2 times of z. So my dou u by dou z is equal to 3 to the 6 into Lx plus my plus nz into n minus 2z. Okay, now again differentiate. This is called double differentiation because I'm 2 times I'm differentiating, so it can witness 6n. Now I'm differentiating with respect to z. This will become 0, this will become 0. 0 plus nz is n minus differentiating of 2z will be 2. So dou square u by dou z square will become 6 into n minus 2. This will become 6n into 6n square minus 2. So consider it as equation number 3. Now it's a very important step that while double differentiating with respect to x, we got 6l square minus 2. Again with respect to y, we got 6m square minus 2. With respect to z, we got 6n square minus 2. And one more condition is given in the question is L square plus M square equal to 1. So add these three equations. Dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square is equal to, this is 6L square minus 2 plus 6M square minus 2 plus 6n square minus 2. This part will become 6l square plus 6m square plus 6n square. Okay, and minus 2 minus 2 minus 2. And this will be 6 times of, if I take common 6 from these 3, L square plus M square plus N square, and this will be minus 6. And if you match this bracket term with our condition, I can write it as 1. 6 times of 1 minus 6. So 6 minus 6, which is equal to 0. So what we have to show? We have to show dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square is equal to 0. So hence proved. This is our required answer.